Now, limits at infinity are not the same as infinite limits. A limit at infinity happens when we're looking to understand the behavior of a function for a very large x value, either positive or negative. So before, with infinite limits, x could be anything, but then y became very large, positive or negative. But now with limits at infinity, x becomes very large, either positive or negative. And we know, write it this way. So x is not technically approaching any one number, but we write it this way to tell that we're plugging in the values of x into the function that are bigger and bigger positive, and this one bigger and bigger negative, and we're looking at what happens to y. Okay? So using this graph as an example, let's see what happens when we clear my calculator here on the left. Let's see what happens when x becomes very, very large. I'd plug in very, very large values of x. So they would be on the right side. Bigger and bigger x values would give me y values that are closer to this. So y would approach this y coordinate here. So that would mean that the limit of f of x when x goes to infinity equals to m. And when it goes to minus infinity, we're going in this direction. So that would be L, which is the correct y coordinate that we're approaching. Okay? So this is how limits at infinity work. Always be careful with the difference between limits at infinity and infinite limits, because for example here at a we would have a infinite limit. So here we would have that the limit as x approaches a of f of x equals to plus infinity. So the result of the limit is infinity, which means this is an infinite limit. So a limit at infinity happens when x becomes large, either to the right or to the left. So let's use these ideas and try and understand how we can calculate some other limits at infinity for some known functions using graphs that we already recognize and remember. So let me go back to blue. If we look at the cosine function, cosine function, the graph of it, as you know, is a periodic function. It looks like this. And it does the same to the left. So it's going to oscillate up and down forever. I'll even erase part of it because this is unnecessary. Since you understand it, it's going to oscillate between -1 and 1. So this is 1. This is -1. There's no one number that x approaches as we're going to the right because it keeps changing. It doesn't approach one y coordinate. So this does not exist. Same here when x is going to minus infinity. And that's for the same reason. When x is going to the left, right? X going to minus infinity means we're going to the left further and further. It's going to keep oscillating. I don't have space on my screen for that, but it's going to keep oscillating up and down just like it did on the right because it won't approach any given y value, so it also does not exist. However, let's take a look at e to the x. I know my y coordinates, or excuse me, I know the graph of my function, just like this. Looking at the graph, as x goes to the right, I'm going this way. X goes to plus infinity. The more x grows, the bigger this y value becomes. And you can see that, let me bring my calculator back. You can see that if I plug in some very large y values, let's say, where's e on that? So that will be alpha E2. So let's plug in some very large y value like 1,000. So the result will be why is it not giving me a decimal, huh? Maybe that's too much for my calculator, isn't it? So let me maybe pick a smaller one. You see how fast it's growing because my calculator couldn't handle it. So if I do 100, can it handle it? Apparently not. How about just 10? Let's see if it can handle e to the 10th power. Apparently you can't give me an approximation, but this is going to get very big though, because they're multiplying e times e times e over and over again, and the result is getting bigger. Since my calculator isn't helping me, I'll tell you what I expect. So if I plug in, I know e is roughly 2.7. So e squared is going to be about 2.7 squared. E cubed is going to be about 2.7 cubed. This thing is bigger than 2, right? So this is a lot bigger than 8, for example, bigger than 2 cubed. So e to the 10th is going to be a lot bigger than, let's say, 2 to the 10th, right? Because e is bigger than 2, and 2 to the 10th is big. The bigger this becomes, the bigger 10 becomes, the exponent becomes, the bigger e to the exponent becomes, because we're multiplying e times e times e over and over again. So the result is plus infinity. Calculator didn't help much, but we can still use what we know about the algebra and the graph to reach our conclusion. Now, maybe now this calculator is going to work. Is going to help us. So let's see. I won't repeat the graph, but now we're making x go to minus infinity. We're going to the left. X is getting more and more negative. So like x equals minus 1,000. Right, it's going to live over there. Maybe minus 1,000 is too much. Let's try minus 100. If I plug in, let me try again to see. E raised to minus 100. Let's see. Calculator is not collaborating. What if I just do minus 10? Yeah, it doesn't seem to be collaborating. But this helps though, this idea that e to some minus, let's say 1,000 equals 1 over e to 1,000 helps us, because the more negative this becomes, the bigger this becomes, and then you have 1 divided by something very big, so the answer is going to be a very small number. Small meaning very, very close to 0. So this limit equals to 0. Not sure if this was helpful because the calculator didn't work, but this is more or less the idea behind limits at infinity.